Back to the Earth Science Regents Review videos. Today we're going to be talking about Earth's revolution and seasons. So the first thing I want to ask you guys is I want you to tell me which side of the image, if you were to be standing on either side of the image, which side of the image is experiencing warmer weather, and how do you know? Take a second to answer that. If you said the side on the left, then you guessed correctly, because in the summer, the sun is higher in the sky, which means the sun rays have a higher angle, which causes the sunlight to be spread over a smaller area on the ground, which basically means it's more focused. It's a more intense sunlight. In the winter, if you notice, the sun is lower in the sky throughout the day, and therefore the sunlight is spread across a larger surface area of the Earth, which means the sunlight is less intense. So what causes the sun's angle in the sky to change at different times of the year? What causes the sun to be low in the sky in the winter and high in the sky in the summer? Well, actually, our Earth is tilted. And you can see the axis is tilted at an angle of 23.5 degrees. So the observer here is standing at about the same latitude as New York, at about 40 degrees latitude. And if you were to imagine yourself standing where this little blue man is standing, the angle of sunlight that he would be receiving is pretty high, because the North Pole, which is the top of the northern hemisphere where we live, is currently tilted towards the sun. So little blue man here would be receiving a high angle of sunlight. Now, if we were to move to down here in the southern hemisphere close to Antarctica, his brother, blue man 2, would be receiving a very low angle of sunlight, and which would be a very cold temperature. And this is the reason why the Arctics are colder than, let's say, the equator, or even places that are close to the equator, because they're always receiving a very low angle of sunlight. They're always receiving sunlight that's relatively spread out on the surface. And so, especially in the summer, when the North Pole is tilted towards the sun, blue man at 40 degrees north latitude, close to where New York is experiencing a high angle of sunlight. So, but why does it change for New Yorkers? Why do we have a high angle of sunlight in the summer and a low angle in the winter? Well, to understand that, we have to look at the revolution of the Earth around the sun. So here's a diagram that shows us the revolution of the Earth around the sun. If we go here to the summer, we'll see that the summer solstice occurs on June 21st, which is the first day of summer. It's also the longest day of the year for people in the northern hemisphere. The top of the Earth is tilted towards the sun. Making the angle of sunlight to be higher in the sky. If you notice, 6 months later, or 1/2 orbit later, the North Pole is tilted away from the sun. This would cause the sunlight to hit us at a slightly lower angle, which gives us slightly colder temperatures during those months. And then the two positions in between are the spring, when we're coming out of winter, and the fall, when we're coming out of summer, going towards winter. So what causes the seasons? Well, it's the tilt of the Earth. So we live in the northern hemisphere. When the North Pole, the top of the northern hemisphere, is tilted towards the sun, we experience a higher angle of sunlight in the summer, making the temperatures warmer. In the winter, we experience a lower angle of sunlight, making temperatures lower. So let's practice this exercise. So I want you to imagine that you live in New York, and Earth is obviously always orbiting the sun. I want you to tell me what season is being experienced at position A. Did you answer fall? Because then you guessed correct. You can see on the diagram here that, well, actually, it really should have arrows showing you the direction of the Earth's movement. But you can see that after summer, the Earth moves this way, and the next season is fall. After fall, the Earth is still tilted, but now in this position, it's tilted away from the sun. What about season B, when the North Pole is tilted away from the sun? That should be fairly easy at this point, and that's obviously winter. And one thing that I would like to note is that people who live in the southern hemisphere, in countries like South Africa or Australia, they experience the opposite season to us at different points of the year. For instance, when it's our summer, it's winter in the southern hemisphere. And when it's our winter, it's their summer in the southern hemisphere. So when we're celebrating our holidays like Christmas and Hanukkah and stuff like that, Australians and South Africans are soaking up some rays at the beach. And they're off from school too. So that's it for the Earth seasons and tilt of the Earth and Earth's revolution. So just to review, what causes the Earth seasons? Well, it's due to the tilt. When we're tilted towards the sun, we have summer. When we're tilted away from the sun, we have winter. What causes this angle of sunlight to change throughout the year? Again, it's the changing tilt of Earth. A higher sunlight angle is associated with warmer weather, which means a lower sunlight angle is associated with colder weather. And Earth's tilt is always 23.5 degrees, but it changes relative to the sun as we revolve around the sun throughout the year, 365 days, which is just to say that the Earth's tilt never changes. It's just sometimes the top is tilted towards, or the North Pole is tilted towards the sun, and sometimes the South Pole is tilted towards the sun. All right, so that's all for Earth's revolution and seasons. I'll see you at the next video. All right, guys, have a good day.